this collection of videos, we are going to remind ourselves what the definition of a left and right coset are of a subgroup of an arbitrary group, and then we are going to work a variety of examples. So first, I'm calling this a reminder because at this point we've already gone over the definition of a coset, and I don't mean cassette, like from Les Miserables, although we do have historical roots in France here. Let's suppose that G is a group, and H is just any old subgroup of G. Then we're going to define the left and right cosets, which are named after the coset representative, the element that we're calling here little a. The little a in the left coset goes on the left-hand side, and then the variable h is thought of as ranging not over the whole group, but just over the elements of the subgroup H. We're going to look at the set of those items, and those items will be called the left coset, again, because the A is on the left of H in G. We can define a similar thing called a right coset, where the little a is on the right, and we're doing the same procedure, fixing little a and allowing little h to range over all of the elements of the subgroup H, and looking at the collection of all such outputs there. And that set is called the right coset of H and G. Let's do our first example as a finite example, picking to compute the right cosets of a subgroup that I would have called H, but for reasons that will become clear in a moment, have chosen to call K here, where we're working in D4, the group of symmetries of a square, and K is our subgroup, is going to contain the identity, also thought of as R0 here, and the motion of the square that's reflection along what we're calling the line y is equal to x there. We're going to look at this subgroup of two elements inside of D4, and we are going to compute the right cosets of this subgroup in D4. Now for this example, since we're dealing with a finite group, and we have a Cayley table representation for this group, it's going to be very easy to find the set of right cosets of this subgroup inside of G. What I'm going to do might seem a little strange, but my subgroup is going to consist of R0 and this element y is equal to x, and because that is my subgroup and those are the two elements of the subgroup K, which I've named K because I have an element of my group named H here, I kind of want to put those two elements together. So I am going to rearrange my Cayley table and take this row right here and move it so that it's right next to my R0 element. And these two elements right here form my subgroup. So I'm highlighting them because they're the only part of the Cayley table that I'm considering. My Cayley tables, I read the entry on the inside as having performed this action first and this action second. So if I want to compute the right cosets of this subgroup inside of G, what I'm doing is reading off these sets of two elements in the columns of G. So my cosets here will be R0 along with y is equal to x, R90 along with v, R180 along with y is equal to negative x, and R270 along with h. Now notice that there are 4 other cosets that are in this table. However, because cosets are sets, you'll notice that things match up in a particular way here. This is easiest to notice right here. The right coset of R270 with this particular subgroup is the set of elements R270 and H. The right coset of H with these two elements is H and R270. The elements of the coset are generated in a different order, but how the elements are generated is not particularly important. What matters in the end is the collection of elements that are output, and the order is totally irrelevant, and therefore this coset and this coset are exactly equal. And you'll notice that the same thing happens with all of the other cosets. R90 and V V and R90, R180 and Y is equal to negative X, Y is equal to negative X and R180, and so on. So just to summarize, the right cosets of the subgroup K inside of this particular group D4, which I could call G if I'd like, those cosets were this coset, this coset, this coset, and this coset, as seen in the Cayley table here.